Welcome back, Math 20-3. Today's our lesson will be about the new chapter, Chapter 5. You can find it from your workbook, page 231. And Chapter 5 is everything about scale representation. Although we don't need this type of drawing activity so far, but we are going to use a bunch of proportional reasoning skill. So, Chapter 5.1, like I've mentioned in this title, scale drawing and models, these guys will not going to be, taught in one day. It's going to be divided into several different sections. Today's lesson is a little bit of reviewing of proportional reasoning. Which means we're gonna go back to our ratio for a bit. And the ratio combining with measurement, basically. Alright, so without further ado, why don't we all go to page 232. Now, here's what I will ask you to do. Let's solve this question together. The ratio of the length of the width of a rectangle is 5 to 3. If the rectangle is 24 centimeter wide, how long is it? Now, I know that I taught ratio method using a number, another number way. From now on, we are going to do Canadian way too, using fractions. So I'm going to do both calculation style. First thing first, we have the ratios given, 5 to 3. Remember that according to this question, length is 5, width is 3. And the other clue that is given is width is given as 24 centimeter, and we need to find out the height, length is what we need to find. We're going to use two different methods. One method is what we already know, basically, from previous chapter 1. Now, ratio method. You put 5 and 3 and have an equal sign. Know the fact that length is on the left side, so length should belong to the left side, which unfortunately we don't know. So you can put unknown x, l, whatever you want to call. Width is on the other side, which means I need to put the actual measurement of the width on the right side. So I have 5 to 3, which is equal to x to 24. We can multiply what's inside and what's outside because these two equal together. So 3x is equal to 5 times 24, and that's centimeter, which means 120 centimeter is equal to 3x. At this point, I want you to do opposite operation, which means divided by 3, and x thus is equal to 40 centimeter, and that's my length. This is one of the methods. Again, the solution in the workbook doesn't give you that. Now, Canadian method. This 5 to 3, you guys need to change into fraction. It really doesn't matter what number you want to put it as, numerator or denominator, but I kind of like to put unknown value on the top, known value at the bottom. What I mean by that is length we don't know, right? So that means length over width situation. That is equal to length over width. And one of the side over here, will be my ratio. 5 to 3 will go inside on the left side. So length is 5, width is 3, and when it comes to the other side, length, which is we don't know, so x, and width, which is the value that we know, 24 centimeter, like that. Now, opposite operation of this x over 24 is what I need to do. These two are dividing together, so opposite of division is multiplication. So long story short, 24 centimeter times by 5 over 3 is equal to my x. 3 and 8 cross multiplication. You can simplify these because they have common factor 3. So 3 divided by 3 is 1. 24 divided by 3 is 8. Now 8 times 5 is equal to 40 centimeter. And that is my answer. Although it doesn't matter which method that you use, ratio method, fraction method, but I believe Canadian curriculum use fraction as a ratio a lot, so that means you have to be familiar with the skill that you have to face, and some of those calculations that the questions give you. It's just a necessary work, in my opinion, setting up the two fraction on purpose, but again, I'm gonna use each of the method differently. All right, I want you to go to page 234. Your to-do list will be given to you, but in any case, the scale diagram. Before we draw any type of diagram, we need to understand what is a scale factor. Scale factor, although the definition is given on this page, I'm going to simplify. The scale factor is mathematical way of showing, so it is a ratio of two different figure. Generally, it involved with their measurement. But the way that you apply the scale factor is you have to multiply this certain ratio, if you will, which is scale factor, to one of the object. Figures, value. And by doing that, the scale statement can be communicated through this scale factor, and scale factor tell us the step-by-step. Scale statement is a ratio that shows the relationship between the size of two objects. So if we don't know this scale statement, and that's something like what we see, width to length, something like that, we cannot figure out our reduced shape of a diagram or enlarged size of a diagram. So I'm gonna do some example on page 235. I'm gonna do only one of an example. Actually, since it's 9 minutes so far, I think I can do two actually. Scale statement for a reduced or enlarged object, and we need to calculate the scale factor they use to create reduced or enlarged situation. Now, scale factor, you can consider this as a formula if you want. I want you to think it as a simple fraction, which is one of the reasons why Canadian method of ratio play a huge role in here. Model, think about this as a either smaller than original or larger than original. Because scale diagram is one of those method to draw something that is original into a smaller size or larger size, but without damaging this ratio. So let's go with the first situation. You don't have to use a ruler. I'm gonna not use a ruler because you guys probably have your workbook ready. Original have 6 centimeter for each of the sides. This is a triangle that have every single side is equal together. Now the model have 3 centimeter. So as you may notice from my original to model, it's a reduced scale. It's not enlarged object situation. Then your first job is figuring out the ratio. Your ratio is basically model to original. Honestly, order really doesn't matter. The model is 6 centimeter and model is 3 centimeter and original is 6 centimeter. So I have these two. Of course, you need to simplify when it comes to that, because centimeter will be gone, so it's actually 3 to 6, which I can divide by 3 common factor on both sides, so it is 1 to 2 ratio. And next step is we're basically substituting this into scale factor. My 3 centimeter part is now reduced to 1, so my scale factor is equal to model, which is 1, original, which is 2. So my scale factor is in fact 1 over 2, basically. That's what I want to point it out. Now, this is two-dimensional situation. Three-dimensional situation. Which is my B situation. I have a rectangular prism, 1 centimeter, 2 centimeter, 3 centimeter, and I have in this time, unlike the previous situation, I have definitely enlarged situation. Have it in your mind, folks. I have 5 centimeter, 10 centimeter, 15 centimeter. Now, first thing first, what side should I choose? It doesn't matter which side you choose. So that means let's pick one of those, 2 and 1. So first step, ratio and simplification. My model to original is in fact 10 centimeter to 2 centimeter. Units will be gone because it's common unit. Greatest common factor is basically 2, or any type of factor if you don't remember. 2 divided by 2 is 1, 10 divided by 2 is 5. So my ratio statement, scale statement, is 5 to 1. Now, second step, we'll try to find out our, simply speaking, some kind of fraction to find out scale factor, which is model on the top, 5, original at the bottom, 5 over 1. When it comes to denominator of 1, we don't put as a fraction. The scale factor is just 5. That is today's lesson, ladies and gentlemen. When it comes to any type of, how can I say, application of the scale diagram, know the fact that you have to be familiar. In fact, it's recommended to master the skill of proportional reasoning, either using the ratio method or fraction method. That is today's lesson.